So, good afternoon, everybody.
Good afternoon, sir.
Good
Good, af-
afternoon,
Good afternoon, sir.
good afternoon. Okay. So, I think we were left over with this stack operations. And the last time I have told you an example of how the stack will be used in the real-time operations. So we have also discussed a lot about the stack operations, how we push the data inside the array and how we pop the data from the array. And remember, stack is called an abstract data type. The reason is that it uses a data structure. It's not a direct data structure. So it's a way, it's a protocol of how you insert the data and delete the data. And that is the reason why we sometimes also say an abstract data type, because it provides us the operations of how to push and how to pull it. Because inserting and deleting the data is of different ways. If there is no certain protocol and name for it, then it should not be like that. See, for example, in your networking also, you will say the TCP, IP. So transport protocol, excuse me. Yeah. So we had an internet problem. That's why. So we have something like file transfer protocol, message transfer protocol. So there are some protocols which you need to follow for certain things to work properly. So these are set of rules and operations that you need to follow. So, for example, if you want to connect two computers and send a file, you use file transfer protocol, which you will connect the computers using socket connection first. You make it as a client server and transfer the file, request the file. So these are some of the operations that you do. So, for example, if I want to insert and delete some values in an array, I can do it in any ways, but there should be some standard way of doing that, right? So, it's the way like we once say that it is stack and sometimes we say it is queue. So, I already said to you the example of where the stack is used. The stack is used in a memory where you can have functions calling each other, and function will be pushed into the stack when a new function is called, and after it serves its purpose, the function gets popped out. The last function that gets popped out is the main function, whether it is Python or C or C++ or Java. So this is a real-time example of the stack, and real-world example of the stack is like something we have discussed about the gun and the cartridge, how the bullets will be coming out. So there are two ways that you can say that it is the first in, last out, or the last in, first out. So one, you have to decide about that. And we have also discussed about how the arrays will be used, and stack is not a data structure exactly, because stack provides you the operation type. So we use arrays for performing the stack operations like push and pop operations. So naturally, when we use an array, sometimes I have discussed that the array might be fixed at the current position. Maybe we can give an array and we should fix it for this purpose. And our list in our Python will be used like an array, because we don't have any array data structure directly available in Python like in C and C++ and Java. We better use a list as an array. So for that, what I can do is I can declare like this. So I will just show you Python 3, and I can do it like this if it is really visible to you. So S is equal to, I can say, don't keep 0, because sometimes 0 might be useful to you. It's better that you place none to create it. So you can see a list of certain, maybe the length of 10 elements has been created. So this is the same way that you do generally in C programming, like A of 10. That's all. But here it is not possible for you to do, because list is always expandable. It is not fixed. To make it appear like an array, I have to do it like this. So everything will be none. So remember, instead of none, if you keep 0 or a character or anything, that will be repeated those many times. And now I think you can replace this one easily. None means you imagine like nothing is there and it's a free space. and you can just replace everything with that. And we have also discussed in the last class that the memory never gets deleted with the example which we have discussed about formatting. So memory never gets deleted. Instead, it gets replaced. So once you said it is not my memory, it is not my memory, then it will get replaced with is a fixed array. And you should remember that how many elements on the stack are actually recognized using a border called top. So in this case, our red arrow is called top. So you can see this red arrow which I have drawn. This is called top in our case. So the top always starts at -1, the -1 position. So whenever you want to insert new values inside these things, then your top gets moved on. So whatever the size might be for an array or your list is not very important, but when you talk about what is the length of the stack, it's not the length of an array. The length of the stack is up to your arrow. That means your top. Now, let me write down in 3 columns, like what are the operations that we generally perform in this. I will write it in yellow. So you will have push. So this is a operation push where we receive an element ELE of whatever it might be. Then the next one will be pop. So just you say pop, it will be just running away. Display. Just if you call display, what are the elements up to the top will be displayed. That's what our case, okay, based on the discussion above. So let me write down few things for you. Now I will call the command called push of 100. Can you tell me now what will happen based on the previous explanations?
100th element will be pushed out, sir.
Yes, what did you
100th
say?
element will be pushed out.
Okay, not pushed out. You should say
Oh, okay.
pushed in.
Okay, sir.
Okay, pop out, pushed in. Okay, now what will happen in this particular one? Can you tell me? So, what should the code be like? I will write. I will draw a small thing like this so that you can write something here. Okay, yeah. Uh, okay, this is in red color. Let me make it white. Okay. Can anybody tell me what should be the code here? How do you push it inside this? So when I said that push 100, you need to imagine that 100 will come here. Okay, the element will be 100. So I need to keep the 100 here in this current position. See this one? In this current position, I need to put the 100 here. How do I put it? How do I know? Because every time you need to increase your border, and there itself you have to keep. So 100 will be the last and also the first element that is in the stack. The first thing that you need to do always is to increase your top. So your top will be top plus 1. And then, because this array is called A on which you are performing the stack operations, your A of top will be equal to your element that you received, that is nothing but your 100. So you will write 100 here. So based on this, can you now tell me the code, a simple code for this? What is the first thing that I have done here? What is
Top
the
is
first step?
equals to top plus 1, sir.
Yes, top is equal to top plus 1. What is the next operation, next step instruction I have done? What is the array name?
A, sir.
A. At what position I am keeping 100?
A of
A of,
0 is equals to push of 100.
if you say 0, that's not a very big case. Every new element will be at the top position. Can I write now top?
A of top, sir. Yes, sir.
Yes, A of top is equal to element. That's nothing but 100. This is a simple code that I have written, right? So Every time when you want to insert the next element, you should be writing the same code. Top is equal to top plus 1, a of top is equal to element. Now, for example, now I will write something like this. Push of 50. Now, again, I think this time the element will be 50. It is receiving 50 now. Okay, 50 it is receiving. Now, again, we go inside and say top is equal to top plus 1. So, based on the instruction, we increase the top. Now, the arrow is the top, which is representing represented with red color. And next instruction is a of top is equal to element. Now, my top is pointing to 1, right? So, a of top is nothing but a of 1, where we keep the element, which is nothing but 50. Okay. Now, I want to display all the elements in the stack. Can you tell me how do I display it? If I call display now, I call the display function. I said something, right? If I talk to you about how many elements are there in the stack, do you talk about all the elements in an array or up to top?
Up
What
to
is yours?
top, sir.
Yes, up to top. So 150 are the only things that are there in your stack. So I will write a small program for this. So you need to tell me what to do with this.
Sir, we will have a for loop, sir.
Yes, correct. So you will have a for loop with that, and let's write the code for this display. So what is the for loop that you write? For I in range. Now tell me what you will write here in the
0
brackets.
to top, sir.
0 to top means it will
Top
start.
plus 1, sir. Top
Yes,
plus 1.
yes, 0 to top plus 1. And after that you simply write print whatever it might be, a of
A of top, sir.
I, not top. It will only
Sorry,
be
I.
a of I, because I starts with 0 and ends at top itself, because you are going up to top plus 1. So all the elements in the array will be in the stack will be displayed. And now the last thing that we need to discuss is about the pop operation. So let me change the color to this. Okay, this is the pop operation. So you know how to display for I in range 0 to top plus 1 and print a of I. That's all. So you are starting at 0 and printing up to top plus 1. So, but if the top is at minus 1 and nothing there is there in the stack, then you have to produce an error like nothing is there in the stack to display. Okay. Now, I will again write something like, before we go to pop, let me write something like push again. So push of 200. So again, it will go to push operation where you will have 200 here as an element. So top is equal to top plus 1 in this case, and a of top, which is nothing but pointing to 2, right? So a of 2 is equal to element. So now this is our answer, 200. The next thing I will call is pop, simple pop. So pop in the sense, if you call it simply, see, we have this pop function which is predefined in our list, right? Don't use that pop function. You need to write the pop function. What is pop? The pop indicates that you want to remove some element from the list itself. Sorry, from the array itself, because we are thinking our list as an array, right? And it is our turn to write the code. So it's not like you cannot rub this 200 and say it is removed, or you cannot take out this block and throw away it is removed. So it's internally, it's not the working condition of the memory. So the good thing that you can do is just decrement top. That's all. That means you're telling that I don't want 200. My stack only contains now 150. I don't want 200. The 200 is discarded. So it is popped out. So for this, can you just tell me the code what I need to write? Simple thing. Only one line of instruction needed in the
Top
pop.
is equals to top minus 1.
Yes, correct. Top is equal to top minus 1. That's all. So that is the reason why the top from 2 to 1 it came. Now I will ask you, if I write something like now push of 1000, what will happen? Can you tell me? Now you receive 1000 as an element here. Now what will happen?
1000 will be added at second place, sir.
Yes, correct. The reason is, as an instruction says, top is equal to top plus 1. So it is there, and next a of top is equal to element, because top is pointing at 2, and so a of top is equal to element. That means you simply need to replace 200 with 1000. So now our stack contains 100, 50, and 1000. So remember these few concepts. This will really help you in all those things. The first thing that you need to remember is that you have to say that the entire stack exists from 0 to the top position, not up to. It is to the top position and up to top plus 1 position. That you need to remember. So for loop, you will write it like that. And whenever you want to push a new element, remember the top should only contain the new element and the latest element. The top will not be in the before position, and you cannot add a new element. The top always points to the latest new element. So that is the reason why whenever you want to push, you first increase top, and wherever the top position is there, then you put the element. That gives you a correct stack process. To pop it, you no need to write anything except top is equal to top minus 1. And again, if you want to display it, wherever the top is there, it will go to top. From 0 to top, it will print every value. So that's simply the stack. So I think it looks like your functions also, right? If I write down the example for this, you can say if the 100 is the main function, maybe just I'm talking about this one. So main function is calling a function 1. The function 1 is calling function 2. The function 2 is calling function 3. And after fulfilling it, the function 3 will be popped out. Next, function 2 will be popped out. It's nothing but like, your top pointer is coming to each function back to main. And function 1 will be popped out. And finally, if your arrow comes to minus 1, that means main is also popped out. This is how your function calling works actually using a stack, and your entire elements are deleted. Now you see, if I call the pop again and again, if I'm calling pop, 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 see what will happen. Now we will go through each element. For the first pop, it will go to top is equal to top minus 1. So what will happen? It will be decremented to one position. For the second pop here, right? Again, it will go to this pop and say top is equal to top minus 1. See the pop functions. So again, it comes back. And for the third pop, again, it will go to this function top is equal to top minus 1. So this time, you see, all the while these values are there itself. They are never deleted actually. So again, you go to minus 1. So this is the end. This is the end of your stack. And further, you cannot pop it. If you want to pop it, you need to give an error called underflow. If you want to push more than 6 elements, that is from 0 to 5, if you want to push more than those 6 elements, then you should say it is overflow if the entire array is filled. So this is a simple pop operation that you should know. So now I will give you 5 minutes of time. Test it yourself. Declare a list of this type with none. Keep all things are none. So instead of see, you can see that all are none instead of this maybe none. They are actually initialized with none until unless you replace them with the other values. Everything will be none. But your task is only to print up to those what we say the top. That's all. Now just try out a little bit, then you will have the confidence. Okay, I know stack. Then I will give you a small puzzle. So if you understand these basic operations, it is very easy for you to write down different things. So I will have a small puzzle for you, okay? And then we will discuss about that puzzle, what idea you got and all. Then in the next class, we can go for implementing the stacks in the linked list. And it will be followed by a series of exercises to make you understand what is stack. So remember these three boxes every time. What is push? What is pop? And what is display? That's all. So if you know these concepts, you can use these lines for lot of instructions that comes in the future. So you can just simply go for writing these statements along with few other statements that is combined, and it will give you the answer. Uh, can you raise your hand if you have already tried it? Anybody and got some answer?
Sir, doing it, sir.
Okay, okay, right. So shall I give another 5 minutes of time?
Yes, sir. Yes, sir.
Sir, I'm getting smaller. Can I share my screen, sir?
Yes, you can.
Yes, sir. Host disabled participants to I'm sharing. Sir.
Yeah, I will do that. Wait. Okay, I have made it.
Actually, done this, sir, but I don't know. Top is saying not different.
Top
Alert from
is
your disk is almost full.
top is. See, because it is all because you have made it as a global and you are directly using it into the functions. So the global top is okay with C programming. So whenever you use a top, it's very easy for you. So instead of directly using top like that, every time you declare top in the main itself, and if you declare top in the main, it's different. Can you write down like classes so that your top will be your class variable and all the functions will be part of your class? Did you understand what I said?
Yes, sir.
Like that, if you write, it will be okay. So you can declare a class called stack, and in that you can declare what we say, the top directly as a class variable. So you can do the same way that you are actually doing it. Send an fixed list like what you have done, right? So do it in the main, like a is equal to none into 20 in a, and just send that a as an instance variable. Okay, you can try out by closing your screen. Okay. Okay. So it is not safe for you to use a global thing for every time in Python. So it is better for you to go to classes. So my simple advice is declare a class called stack, and using that class, you can declare a class variable called top, which is initialized with -1. And don't forget to use self.top every time you are calling top, because even though it is a class variable, for that instance, it will be instance. So declare the functions like push, pop, and display there itself in the class. So they will do all the magic for you. And before you initialize a particular stack, for example, S is equal to the capital S stack of, you need to send the array or the list that is fixed and you are actually deciding in the main itself. So that will be assigned to the self dot class list, and I think you can get these hints, and you change everything, and when you try to display that stack every time, it will get displayed. For displaying, you can simply write down like you can use a hyphen underscore underscore str underscore underscore also. So if you don't want to forget all these concepts that you have learned earlier, try out in different ways with the previous concepts. Amma vachinda? Is it working? When you do it using classes, is it working?
Yeah, trying doing so once.
Okay. Right. Anyway, you will all do it. You can try out in different ways. You will definitely do it because it's quite easy. I want to now discuss with you the puzzle. Please, all of you concentrate on what I am discussing. Slowly, you can go again with your practice with your basic program and then come to this puzzle. First of all, try to understand what this puzzle is. This puzzle is sometimes something like this. Maybe if my array is like this, I might be having a fixed size array, the number of elements 1, 2, 3, 4, 5, 6, 7, 8. So based on the input list, I will declare my array like this, maybe my list itself. So another list I will declare 1, 2, 3, 4, 5, 6, 7, and 8. Maybe 0, 1, 2, 3, 4, 5, 6, 7. Okay, fine. So what is my case is that I will take each element from the list and I will push it. Okay. So push in the sense it will be pushed 1 here. And there is a small condition that whenever your list is looking like this, so I always expect like, it's like you imagine this list like your top. So now you inserted 1 into this. So the next number is 50, right? The condition is that the 50 should not be on top of 1. Did you understand? The 50 should not be on top of 1. For example, when you are, putting your suitcases, what you will do when you are trying to pack. So if there is a big suitcase, you will put a small suitcase on that, right? You cannot keep it like this. On a small suitcase, you cannot keep a big suitcase on that, right? You will never do that. So by default, you will do this. The high, the big suitcase or with a lot of weight will be put underneath and the small one will be put here. So same thing I am doing it here. So the 50 number is having the strongest element. That means which is greater than 1 and you cannot keep it on this. So whenever you are trying to push 50, first you need to check the previous element. The previous element is nothing but the top is here, right? You can easily check what is the top's element before you increment the top and sending the 50. So 50 should be waiting here. Before 50 enters this, you will check whether the top is whatever the ace top is less than 50 or not. If it is less than 50, your task is to just make top minus minus. So that means the top will be here. So what you next do is you now try to push it. That means now you will say again top plus plus and then put 50 here. See what is happening. So instead of putting 50 directly, 50 is greater than 1, you are popping out 1 and then inserting 50 here. Did you understand what did I do? Until now, is it clear or any doubt regarding this? Are the conditions clear? I am not giving you the hint also. Are the conditions clear what I want to do?
Sir, where will be the one, sir, then?
1 will be popped out. So I will tell you more example. So the next is 2, right? 2 can be inserted because 2 is less than 50. Fine. The next is 4. 4 can be inserted. Sorry, 4 cannot be inserted. The reason is 4 is greater than the present top 2. I will use this top as this arrow. Okay, the present top 2 is actually less than the newly insertable value, that is 4. So before you insert 4 inside it, what you need to do, you need to make top minus minus. So your top comes here. The top will be pointing to 0. And now what you will do, you will now increase the top to here. You can do whatever logic you want, but I'm just hinting it. And here you will do a of top is equal to 4. So this 2 will be replaced with 4. Okay, finished up to this. Now the next one is 65. Can I insert 65 by increasing top plus 1 and put it at 2? Can I do that? What should I do now?
We should remove the 4 and 50 and then we finish it.
Yes, that's correct. So first of all, your 65 will be compared with 4. What is the present top? So what you need to do, you have to make top minus minus as we have done earlier, and your top will come to 50. Now again you will check with 50 also. If you check with 50, then it is also less than 65. So what you will do, again you will do top minus minus. This time your top comes at -1 position. So this is the end, right? So next what you do, you will say simply top is equal to top plus 1, because by the time you want to insert, you always has to increase the top, and here you will say 65. So A of top is equal to 65. What will happen to 50? 50 will be replaced with 65. Sorry. So do not bother about 4. 4 now gets replaced with another number if it is there, because our stack is only up to top. What is the next thing? 100. Where? What is the next step I need to do now? 100 is waiting here. What to do now?
With 65, sir.
Yes, compare with the present top, 65. It is 65 is less than 100. So your top needs to be minus minus. So your top goes to -1, and hence it is the end. Because it is the end, the next thing that you need to do is insert. So insert 100. So before 100 inserted, so we will do top is equal to top plus 1. So naturally top is equal to top plus 1. So that is the end, and we say A of top is equal to 100. So this 65 will be replaced with 100. Okay. Now the next element is 3. 3 is waiting here. Can I insert directly 3?
Yes, sir.
Yes, because after comparing with the present top, 3 is less than the top. So naturally, what you need to do is increase top plus plus. That means top is equal to top plus 1. So your top will come here. So your top will come here. And you simply say A of top is equal to 3. That means A of top will pointing to 1. So A of 1 is nothing but 3 now. So 3 will be inserted. Okay, fine. The next one is 30. What should we do with 30 now? What is the present top?
We should compare with 3, sir.
Yes, it should compare with 3. So 30 is compared with 3. So because 3 is less than 30, because the inserting element is greater than the already existing top. So naturally you need to do top minus minus. So top minus minus. Again your 30 will be compared with this top 100. Yes, 100 is greater than, that means the present top element is greater than the insertable element. So naturally there is no top minus minus required. Stop here and you need to insert 30. So to insert 30, what you need to do is equal to top plus 1. So your top comes here. And here you will insert 30. That means replace the earlier value of 3 and insert 30. So the final list or the stack that you have when I want you to display is 100 and 30. So I will tell you why I'm doing this one, because the next exercise that I give you as an assignment will be depending on this one. I'm not giving this as an assignment. It is for your practice. You can apply any logic. If you understood it, you can apply any logic. It's not my logic you need to apply, because see the time complexity and space complexity if you are more interested in the program. But if you want to learn how the stack works in this case, don't think about those complexities. First try out your own logic, whether it is dirty, worst or good or better. Try out. And then I will give you some problem, because that relates to this. I have found a very good problem. And if you know this one, how to do this, you can also do that one. So once again, I will reiterate. My first condition is no large elements should be on top of smaller elements. So this iterates that if you have 3 here, you cannot put 50. This is wrong. This is wrong case. Okay. But if you have 50, you can insert 3. And this I will keep it as a right case. So this is the first thing that you need to learn. So the next thing is that if you want to pop, compare all the top and if satisfying the first, okay, first condition, then that's fine, you can insert the new elements. So that means if you want to insert an element, for example 3, the already existing top, that is the last and latest element that it is pointing to, 50, should be greater than 3. Then you can insert element 3. But if the present top is 3, you cannot insert the element 50. So what you need to do? You need to pop out the existing 3. So how do you pop? First you need to do top minus minus. So it will go to the previous position. If it is not minus 1 and if it is some other element that is existing, you need to compare it. Every time you need to compare it. So see how I am comparing it. For example, if I have these elements, so I will tell you now. So I have 50, 100. Oh, sorry, this is wrong, right? Not according to our rule. Okay, I will do it like this. So we have 2, 50, 100. So what will happen if I thought of giving? Is it okay? No, no, no. This is wrong. This is. I think earlier one is correct. So I should get something like this. Yeah, 100, 50, 10, 2. This is correct according to us, right? And the present top is pointing to 2. Top is pointing to 2. Now, if you want to keep it 200, what you will do? You will first compare with the present top. No, the present top is less than the newly insertable value, and 200 cannot be inserted here. It's wrong. So what you do? You need to just pop out. That means you make top is equal to top minus 1. So here again you will compare the present top to the insertable value 200. So 0, 1, 2, 3 up to this we got, right? And still 10 is less than 200. And so what you will do? You just make again a pop. Top is equal to top minus 1. Again you compare this top to 200. So again 50 is less than 200. You cannot insert 200 here. So it will be something like, if for example this is 1000, let us say 1000. Yeah. So what you do? You will say top is equal to top minus 1. So present top comes here. So now what you will check? So if all the elements are less, until unless you go to top is equal to minus 1, you will go and then increment top and put 200 there. Now you see, now we got 1000 here. So anyway, 200 is less than 1000, right? So the present top is greater than the insertable value. That's fine. So this is where you stop comparing. And now you want to insert it. The simple thing that you do is top is equal to top plus 1. So the top comes here. And simply you say A of top is equal to the newly insertable value. So it will be replaced with 200. So what is your stack now? It is from 0 to the top. So this is your stack. So what are the elements in your stack means it is 1000 and 200 because these are all deletable values. We discarded them. So this is 1200 only are existing here. I will tell you why this is used for. For present time, you just at this moment you practice this one. Try to finish off this. I have told you the entire logic also. Please try to do this problem. Any doubts in this? Understood?
Yes, sir. We understood, sir.
Okay, right. So we can now stop the class. Try to do that. So I will get down the puzzle for you.
Sir,
If you, yeah, tell me.
sir, ఆ స్విచ్చెస్ ప్రాబ్లం ఇచ్చారు కదా సార్ లాస్ట్ టైం. అది చేశాను సార్. కానీ చూసుకోలేదు సార్, డెడ్ లైన్ చూసుకోలేదు సార్, సబ్మిట్ చేయలేదు, మర్చిపోయాను.
ఓకే, బట్ ఇప్పుడు మనం ఏమి చేయలేము కదా.
ఒకసారి ఓపెన్ చేస్తారా సార్ అసైన్మెంట్? అది అంటే కోడ్ ఉంది సార్, సబ్మిట్ చేసేస్తా.
కాదు, అది నాకు మళ్ళీ ఓపెన్ చేయడానికి అవ్వదు, చెప్తున్నాను కదా. అదే ఒకసారి ఫిక్స్ అయిన తర్వాత దాన్ని మార్చడం చాలా కష్టం. నేను ట్రై చేస్తాను కానీ నా వల్ల కాదు అది మాక్సిమం. ఎందుకంటే అవుట్ సైడ్ టూల్ కదా, ఇది ఏం చేస్తుంది అది ఫిక్స్ చేసిన టైంని ఇది తెచ్చేసుకుంటుంది ఇన్సైడ్ కి.
ఓకే సార్.
మనం అక్కడ చేంజ్ చేసినా ఇక్కడ చేంజ్ అవ్వదు.
ఓకే సార్.
ఓకే, మళ్ళీ నేను ఇంకో కొత్త అసైన్మెంట్ క్రియేట్ చేస్తే ఆల్రెడీ సబ్మిట్ చేసిన వాళ్ళందరికీ పోతుంది. సో
మనకి లాస్ అవుతుంది.
ఫస్ట్ నుంచి నేను అందుకని చెప్తున్నా, ఎక్స్టర్నల్ టూల్ వాడుతున్నప్పుడు, ఇప్పుడు విపిఎల్ అయితే కొన్ని నేను ఎక్స్టెండ్ చేస్తాను, చేయగలను కూడా. అదే ఇందులో అవ్వదు, అందుకనే ఫస్ట్ నుంచి మొత్తుకుంటున్నా, బీ కేర్ఫుల్ అని. ఓకే, సో show the code and execute before me. I will tell you when to execute, then I will award you the marks there. Okay,
సార్ ఇప్పుడు చేయనా సార్?
ఇప్పుడేమొద్దు, నేను తర్వాత చూస్తాను. ఓకే,
ఓకే సార్.
but it is not allowed every time. This is the last time I am doing it.
ఎస్ సార్, ఎస్ సార్.